All right, so again, inequalities, just like for equations, guys, get the variable to the same side, right? Now, I always like to get my variable to the same side. I always like to make it positive. Now, I'm going to add a 3x to both sides. Therefore, that's going to give me a 4x, and then I'll subtract a 22 to the other side. Okay, so I have a 4x is greater than or equal to a negative 32. Now, what I'm going to do is divide by a 4 on both sides, and I get x is greater than or equal to a negative 8. Now remember, there's many numbers that are greater than or equal to negative 8, right? You have like negative 7, you have negative 5, you have 0, you have 5, you have 10, you have 32, right? There's tons of numbers that are greater than or equal to negative 8. So what we want to do is represent the solution by graphing. So we can take a number line and we could say like, all right, here's negative 8, and like say, I don't know, here's 0, right? Kind of give like a second number as like a frame of reference. So I always like to start here at my negative 8. It's greater than or equal to, meaning it's going to be a part of this. So negative 8 is going to be a part of the solution. And then we're going to go, where are values that are greater than? Well, it's going to be to like 0, positive, all positive values. So it's going to be going in that direction. All right, now here we have a compound inequality, which is or, right? So the solution, the graphing solution is going to be one or the other or both, okay? So one or the other or both, it's going to be what we call an inclusion solution. So again, what we want to do is isolate. So we just want to solve these separately. So I have r is less than let's say a negative 2. And then or here you can subtract a 1. So I have a 4r is greater than a 14. I think that was, okay. And then divide by 4, and you have r is greater than. Now here you're like, wow, what does 4 divided by 14? 14 divided by like 4, like what the heck is that? Like how many times? Now, you can like, a lot of times like this will get confusing for students. So what I always recommend, like if you have a calculator, like find the decimal equivalent, that's fine. Otherwise, you can also just create this as a mixed number, right? How many times does 4 go into 14? Well, it's going to go into 3 times, right? Because 4 times 3 is 12 with the remainder of what? Well, 12 to 14 is 2. So this is the same thing as 3 and 2 fourths, or we could say is 3 and 1/2, right? So the reason why that's important is like, if I'm trying to guess where this goes on a number line, it's going to be between 3 and 4 because 4 is 16, right? 4 times 4 is 16 and 4 times 3 is 12. So 14 is right in between there. That's where you get the 3 and 1/2. So it could be 3 and 1/2. All right. So now let's go ahead and graph our solution. So again, remember, one of these can be true or both of them can be true at the same time. So we have a negative 2. So let's go to negative 2. Let's put a 0 here. And then let's say like, yeah, I don't know, 3 and 1/2. So here's 3, right? And like here's 4, right? So 3 and 1/2 is going to be right here. And then we'll have a negative 2 right there. Now this says r is less than negative 2, not less than or equal to. So negative 2 is not included in the solution. So it's going to be graphing to the left, right? Because like, you know, smaller numbers like negative 4, if you owe me $4 compared to owing me $2, you have less money, right? So that's why going to the left is going to be less. Here it's saying r is greater than 3 and 1/2. So therefore that's going to be values that are going to the right. Okay. So again, we're going to keep both of them on there because one or the other or both can be true in this case. All right. Here is another compound inequality. And now this one, you could rewrite them kind of like on this. Now this is what we call an and compound inequality. So you can rewrite them kind of like we did in this last equation by using the word and. So let me show you what that would look like. So you could do this as a 2 is less than a 10 minus a 4d. And you could see 10 minus a 4d is less than 6. So you could write it like this. Or if you're okay, comfortable doing this, you can actually just do the operations at the same time inside of here, inside using your inequality. So what I'll do is I'll subtract a 10. Now here, you're kind of doing it like, you got to think of like these inequalities as like both kind of like operations on both sides. So like whatever you do inside, you have to do to the other ends of the inequalities, right? So if you're kind of confused, then don't listen to me and just do it this way. All right. But if you understand kind of what, again, this is a summary, guys. So if you understand how to do this, then you can kind of do this a little bit quicker. So 2 minus a 10 is going to be a negative 8 is less than a negative 4d. And then 6 minus 10 is going to be a negative 4. Okay. So now we're going to divide by negative 4. And again, you have to do that on both sides. Now, again, what happens when you multiply or divide by a negative number? You got to flip the sign, right? So now this becomes a 2, and now it's going to be greater than a d, which is going to be greater than a 1. All right. So remember the D is less than 2, but the D is greater than 1. So let's go ahead and kind of like show how this works. So we can say D is less than 2, right? But the D is greater than 1. Okay, so remember this is a and inequality. So it's not just one or both have to be true. It has to be both of them have to be true. So we're looking for when are these both going to be true? So let's go and graph these. And what I like to do sometimes is graph these again separately so we can kind of see. So we have, let's say, a 2 and we have a 1. Okay, so it says D has to be less than 2. Okay, so it's an open circle. It's going to be that way. And D has to be greater than 1. So open circle that way. Now, again, when are these both true? It's between the 1 and the 2. Now, again, 2 and 1 are not included, right? So now I can just go ahead and kind of like erase the rest of that and can say that is going to be the graph, right? That is when they are both going to be true.